We're looking at 2.1. And 2.1 begins with the definition of percentile. And the percentile is the percentage of values in a distribution that are less than the individual's data value. Now, the other book we had said less than or equal to, which is really the definition that I adhere to. But either one's fine. You're not going to get a question where that's a contradiction. I'll show you where it could be, but it won't happen. It won't happen on the AP test. So what does that mean? Well, here's a cumulative relative frequency graph. And in the book, we're on page 93, but just to tell you, to communicate this to you, I used the global scoring distribution for the AP stat scores from 2018. And in 2018, here's what happened. 14%, 14.6% of the total students in the cohort, everybody that took the test got a 5. 21.2% got a 4. So that's 35.8% is the sum. That's the cumulative. So list of partial sums over here in this last column. And that's what you would, if you were going to come up with a graph for this data, in terms of what's on page 93, you would use these numbers. These would be the heights, okay, till you get to 100%, because that would include the kids who didn't do well. Z-scores, okay, so two things are, I don't think percentile is new to you, but you might not have heard of it in a while, but Z-scores, that's your standardized score. That's the language of the course, okay? There is no, they're important. So I'm comparing the Z-scores to a transformation that you're familiar with. So here's a composite transformation. Ready? It's the line y equals x. And what's been done to it? X has been expanded by a factor of a, and y's have been expanded by a factor of b. And the graph's been slid, h to the right, up k. And you're tired of looking at that from calculus, but that's what a z-score is. You're saying you're taking the step and you're expanding it by a factor of the standard deviation, whatever that value is, and then you're sliding it for what the mean is. So you'll see what that means when we get into this, but this is a composite transformation. It's a slide following a scale change. Okay, so again, if we do this, look what happens. If I have the mean as the measure of center and the measure of spread standard deviation, the book calls spread variability, they're synonyms. The shape, it might be approximately normal, it might be skewed. If it's approximately normal, that's when you're going to use the mean for the center and the standard deviation for the step. If the data is skewed, yes, you should use the median as a measure of center, but you can't do this. You can't use median with standard deviation. It doesn't make sense, okay? You can't use IQR with mean. So then what do? When we slide something, it has no effect. It moves the center, but it doesn't affect the shape of the spread. So we're just going to get right to a couple questions in regard to percentiles and z-scores, and you're going to go to, we're going to skip 9. We're going to come back and do that together. You're going to go to 1 and 15, please. They begin on page 104. All right, so we're going to pick up where we were. We're going to look at number 1. All right. So number 1 says, This dot plot represents the number of pairs of shoes. And there's 20 people in the set. It says Jackson has 22 pair of shoes. So you can see the dot above Jackson. That's why we went here. Here's Jackson. Ready? So there's 2 people that have more pair of shoes than Jackson does. There's 20 people altogether. So there's got to be 17 over here that have less shoes than Jackson does. So he has more shoes than 17 20ths. So that puts him in the 85th percentile. Okay. And then B says Raul is at the 45th percentile. So 45% of 20 is 9. So that means Raul beat 9 people. Ready? 1, and 3 is 4, and 1 is 5, 6, 7, 8, 9. This has to be Raul there because there's 9 dots to the left. So he must have the 10th most number of shoes, and the 10th dot from left to right represents 8 pair of shoes. Okay. Then you use that same distribution to deal with 15. So for 15, it says Jackson had the 22 pair of shoes, has a standard score. The z-score is 1.1. So I took this. What is the z-score? The algorithm is z-score equals the data point, take away the mean, divided by the standard deviation. So what have you got? You've got this right here, this algorithm where you have 4 unknowns. So if you substitute values for 3 of them, you can solve it. Okay? So what it means is he's a standard deviation of a little more than 1 above the mean. Now, that's not really, if you look at that data is skewed. So you really wouldn't talk about standard deviations and measure of spread. Okay? But they did. So now what? It tells me for 15B, the standard deviation is 9.42. Solve for the mean. Well, that's the only unknown. So what do? You multiply both sides by 9.42. You add a negative 22 to both sides, and you divide by -1. And you would get negative 11.638. Then what? I went to the calculator and I did this. You didn't have enough time to do this, but just make sure you can follow. I put in the number of shoes and I made a frequency distribution. So the dots above 4 shoes, that was the minimum. There was 1 dot. 5 shoes, there were 3 dots, and so on. I then did stat calc 1 for list 3, where list 4 was the frequency list, and I got this output. Now, does that make sense? This number is what the book told us for the standard deviation, but they rounded it. But that's where they're getting it. Remember, we told you to use, that's not all of the, ready, it says, surveyed a random sample of 20 male students from their large high school. It's a sample. So we should use the sample standard deviation for the step. And because they rounded it in the textbook, we're not going to get the same mean as they got. It's going to be close. We got a mean of this. There's the graph link for it. And this output's saying 11.65. Either way, that's where the center is. It's between 11 and 12. Okay? But the median would be a better measure of center because the median is resistant to outliers. And the fact that they jammed this problem in there, you shouldn't have, you shouldn't use mean and standard deviation for a skewed distribution, but we're just walking through this to see how it works. Okay. So number 9, I didn't have you do, but we're going to go over that together. So for number 9, we're on page 105. There's a picture. Whoop, too far. So here's the picture. This is a cumulative frequency graph. Cumulative relative frequency graph. I'm sorry, cumulative relative frequency graph. And this is the time it took to run 50 yards. Okay. Now, keep in mind, lower time is better. But this is the sum of what proportion of the kids ran that time or faster. So when you get to the pokey kid over here, 10.3, that's everybody in the data set. That's the sum there. So 8 seconds is about the 75th percentile. This is unusually slow. So go back to the graph. Here's 8 seconds. I go up from 8 seconds. Ready? You only beat 25% of the runners. Ready? Because it's better to have it's better to have less time to run. The 20th percentile is about 6.7 seconds. If you ran that 6.7 seconds for your time, you beat 80% of the people in the class. Okay? So that's that for 2-1.